So when it comes to representing our points in the polar coordinate scheme, we can always adjust, that is, flip our radial position. Our radial length can become positive or negative, and then we can always change the spin to end up back in the same way, just winding maybe in the opposite direction or a full rotation more. So, for example, we can find equivalent representations of the point 5 pi over 4 in which we have a positive radius and a rotation, that is angle theta, between 2 pi and 4 pi, or we can make the radius negative but still keep our rotation between 0 and 2 pi, or we can keep it positive and then take a negative rotation between negative 2 pi and 0. So with this point that we have plotted in that location, with the point 5 pi over 4, we can adjust it in that first case by keeping our radius exactly the same and changing our angle by taking another full revolution all the way back around. And so if you draw the picture, it looks something more like that from your perspective, wouldn't it? But one equivalent way we can talk about it is instead with the point 5 9 pi over 4. Take the full rotation and end up in the same place. Alternatively, for our second case, we can instead take our point and flip the radius over to the negative side, but then bring our rotation back around to where we want to be by having our value pi over 4 and adding to it another half rotation pi, which would land us at the point negative 5 pi over 4, which is actually the same as where we started. And then finally, I'm a little bit short on space here, so I'm not going to keep my nice single line, unfortunately. We could also take our point, keep the radius positive as it was, a positive 5, and instead have our rotation come around in the negative direction. So we take that rotation, but then come around from the bottom, where we would have pi over 4 minus 2 pi for that, because we're going in reverse, and end up at 5 negative 7 pi over 4. And we could keep going if we wanted to. We could take something like this and add another full rotation, or go this way and add another full rotation, or throw some half rotations in there, maybe go negative, and then make our angle negative as well. And then we can just keep adding more and more rotations as we want to. It's a nice thing about the circle, but it's also kind of a worrying thing that when we have any point, there's really no one certain way that we have to represent it. But usually, we do like to keep things as simple as possible. We don't worry too much about getting every single way that we can talk about these points, because we'd be here for a while. Usually, when we're looking at these things, we stick to representations like the one we started with, the most natural representation. And that's what we're going to be looking at when we're talking about our next work, where we are going to and from rectangular to polar and polar to rectangular. That we like sticking to our nicest way to look at points in terms of the polar coordinate scheme.